Hello, good afternoon.
Good afternoon.
Thank you.
Afternoon, sir.
Good to have you joining for today's session.
Good afternoon.
Thank you. Okay, so today, the chapter we are discussing today is data structures. So, without further waiting, data structure, you think of it as a way the computer stores collection of data or collection of items in memory in an efficient way. So that's data structure. A way for the computer to store a collection of data points or a collection of items in memory in an efficient way. So in this class, we will be discussing the following categories of data structures. The first here is a list. Second is tuples, then dictionaries, then sets. Although this order is not maintained in delivering the class, and you shall see that as we proceed. Okay, so list. List is no longer new to us. We have discussed it in the second class of this training program. And I have also left a link to the class here where you can read the notebook I was used to deliver it, so for a refresher. Some parts of it is covered here, but I strongly recommend that if you didn't practice the notebook of that class very well, try to go back and do that here before you proceed to this. Okay, so here we'll be discussing the methods of a list, or some methods of a list. Okay, so I have listed out a few here, and as we also proceed out, I added a few more. So here we have append, insert, pop, remove, and extend. So here I just created a list of students, and that's what we'll be using as illustration as we move on with the class. Okay, so this is the list. So first here, let's consider append. If you remember from the previous class, we said append is used to insert an item. Not necessarily a string. This is an error, please. Let me correct it. Insert. Okay, so it inserts an item in a list. Append can only insert at the end of a list. So that is that's a very important property of append method. It can only insert at the end of a list. Should you wish to insert anywhere else, you have to look for a different solution to that, and we're going to see that as we proceed. So in this example, to this existing list we have here, I'm appending another item. So the item I'm appending is Lawal. Okay, so here we have the list, the new list: students, Lawal, Ubong, Nana, and another Lawal. Okay, so that's append. However, I said, okay, what if we wanted to insert not to the end of the list, but maybe to the beginning or to a particular index point in the list? How do we do that? So there is insert method. So this insert method takes two arguments. The first specifies the index location you want to insert it, and the second specifies the item you want to insert in that location. Okay, so here we're inserting at index 2 the item Nana, in this case the student Nana. So let's go back to this list here. We have Opui, we have Lawal, we have Ubong, and we have Lawal again. So index 2 is this Ubong position. So what insert function simply does is it moves Ubong to the right and places the new item in between Lawal and Ubon. In that situation, it will be occupying the index location of 2. Okay, so let's run it. If you run it, it's not going to, because it does not return the list when you run it. So you have to still call the list to know what you have inside now. So I run it, and you can see it. Nana got inserted right at index 2. Okay. So the next here is the pop method. So pop method removes an item from the end of the list. That is if you don't state the index location you want to remove it from. So however, if you state the index location, it removes the item at that index location. Okay, so let's see this example. We're saying pop the item at index location 0, and that is the name Okwi. So the good thing about this pop is it removes it and brings the value out for you. It doesn't just remove it alone, it removes it and brings it out. So let's see it here. Although I ran it before. So you can see it brings Okwi, which is the first index item here, or the 0 index item rather, here. So let's try just pop without specifying the index location. So if you check here, the last item here is Lawal, and that's what it simply brings out for us. So if we were to check the list at the moment, we'll see that it no longer has Okwi and Lawal in it. Okay, so let's see remove. We have seen pop, but how differently can remove act? So the good thing about remove is it allows you to specify the item by the item itself. You specify the item you want to remove rather than by the index location. So in this case, I still want to remove Lawal from, but it is also important to notice that you can only remove the first instance. If there are multiple instances or multiple occurrences of that item in the list, it will only remove the first instance of the item. But if you want to remove all the instances of the item, so you can try to remove it all. Okay, so here, we're removing Lawal from it. And now from the 3 names we have here, it is down to 2, no longer having Lawal. So keep in mind that if you had multiple instances of any item you are removing, it will remove the first instance. So assuming we had Lawal, the way we have Lawal here, if we have another Lawal at the end, for instance, or anywhere else apart from this first, it's only going to remove this first. So if you want to remove all, you have to continue to call this remove on Lawal until it has removed all the instances of Lawal in the name, all the occurrences of Lawal in the name. Okay, so that's remove function, remove method rather. So going forward, we will discuss extend. So the extend method is used to merge an iterable to an existing list. So you have a list and you have another iterable. I've explained what an iterable is before. An iterable is a collection of items. It could be a list, it could be a tuple, and it could also be a set. Okay, so let's see it here. You pass in an iterable to the extend method, and it adds the new or all the items in the iterable to the existing list. Let's see. So that's it. I mentioned that it could be tuple. So let me change this to a tuple. So yet again, it adds Tayo and Ubong the second time. It had added them here when I ran the cell before, and it's adding them again the second time. So I still want to see if it would work with a set data structure, although it's unlikely to work for reasons that I'll explain later. Let me just check. Okay, it works. Yeah, it works. Okay, so it works with list, it works with tuple, and it works with set. So let's proceed. So clear is the next method we'll be discussing. What clear simply does is it removes all the items in a list without removing the list itself. So all the items in a list without removing or without deleting the list itself. So let's see it. So here I'm just simply creating a new copy of student. So of course you can see, let's try to see the new copy, what it looks like. New list. Oh, sorry. Okay, so that's the new list. So on this new list, we're trying to clear it and see what it's going to return. Oh, it returns an empty list. So no longer having anything in it. So before going to the next method, let me quickly chip in the delete. The delete statement. So delete statement is simply used to delete a list or any object entirely. So any object you have and you want to simply delete it from the memory of the system. So you simply call delete on it. So here, let's delete new list so that we no longer have anything called new list. So this line is going to give us an error here. Remember, it's currently an empty list. So let's see. So after deleting it, I'm trying to call something I deleted which no longer exists. So it tells me that new list is not defined. So the name new list is not defined. Sorry, let me add. Okay, so going forward, we have count. So count simply does what the name says. It returns the number of occurrences of a given value. So here the value is Ubon. So let's see what we have in our students list before we run this. Sorry about that. Okay, students. So we have multiple occurrences of Ubon. So let's do the count here and save ourselves the labor. So Ubon occurs 4 times in the list student. So let's move forward to index method. So I'm quite sure we've mentioned index well enough in all of our classes so far for you to know what index does. You can already imagine what this method is going to return. It's going to return the index location of an item in the list. So here you pass in your item X and it gives you the index location. So here we want to get the index location of coupon. But remember, keep in mind that it's going to return the first occurrence as well. The index location of the first occurrence. Okay, so here, let's run this. So the first occurrence of Ubong is at index 1, and you can see that here, just after Nana. Okay, so here we have another method that allows us to sort the content of our lists in either ascending order or descending order. Or let me say in ascending or descending, let me just put it that way. The default argument is ascending. It sorts it from start to end. Let me just put it that way. It sorts it from start to end. So if you're sorting a list of, say, strings, it creates, because the strings you're sorting, the strings you are sorting here, the items that are strings that you are sorting, some of them could be number, for instance. Say you have in a list, you have maybe number 1 as a string, then you have another item that is a name without number, then you have another one that is a character. So what this sort does is it gets the ASCII encoding, the character encoding of that string, because each string, this lawal is not stored as lawal in the computer's memory. The computer converts it to a numerical value before it stores it. So when you're trying to sort, what the computer simply does is it gets the equivalent, the numerical encoding. Let me just put as numerical encoding of that string, and that's what it uses to sort it. So here, let's just call sort without passing any arguments to it. So here we have Nana. Of course, N comes before T, T comes before. These two are the same, so it does not matter. It just uses the order of arrangement in the original list. Then we have U, which comes after T. Then we have, okay, U. That's just all. So you can also reverse this list by passing the reverse argument as true. So let's see it here. It simply reverses what you have here. Ubon, 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 Tayo, Tayo, and Nana. Okay, so next here we have insert. Insert is not supposed to. Okay, yeah, fine. So what I'm trying to do, I'm trying to show you that if you have a number type, maybe it's integer or float, inside a list of strings, then you cannot sort such a list. So that's what I'm trying to illustrate here. Let me just put an explanation. A list of, I've explained it here, but I'm just putting it here again. Mixed data types. I.e. in a number string. Okay, so let's try it. It's going to return error, sure. So what I did here was to first insert a number into the our new list. I created a copy of students as new list. Then I inserted number into it. So let me print it out here. My new, okay, sorry, new list. Oh, sorry. Instead, I was supposed to pass in the index location first. Yeah. So here, the error says this is an operator, right? Not supported between instances of integer and string. So that means, in order to sort, you have to first compare two values. Whichever is bigger or whichever is smaller is what you use to arrange it anytime you're sorting. And even in the case of alphabets, you still have to do the same thing. Just that alphabet A is assigned a lower number than alphabet B, and in that order. Okay, so this simply tells you that you cannot compare a number and a string. But however, if I decide to change this to a string, so it's going to work just fine. But before I do that, let me run this cell so you can see what my list looks like now. So we have strings here, then we have an integer here, and we have other strings. It doesn't matter where this integer is located, as long as it exists inside this list, you cannot sort this list. But if I were to change it to string, it's going to work just fine. Okay, so there it is, that has been sorted. So let's see our list now, our sorted list. So here, 34 obviously comes before any other number. So like I told you, it's going to convert the strings into their corresponding number encoding. So 34 is a number, so it will always come before any string. All right, we should stop here and resume back at 5:30. So thank you for tuning in. We'll resume back at 5:30.
Thank you.